Hi, and welcome to my talk about Hibernate tips. Let's start it off with a quick question. Who of you knows this situation that you have to implement something that sounds pretty simple and then you recognize, well, it's not that simple to implement and you can't by any means be the first one who has to implement that? Yeah, I think all of us know that. And the good thing is, there is, in the most situations, a good way to solve that without implementing a lot of stuff, because Hibernate provides lots of features that help us to implement the most common business requirements. Before we dive in, a few words about me. Who am I? I'm Thorben Janssen. I'm an independent trainer and consultant, and author of the book Hibernate Tips. And today I want to show you 15 of these tips and how they can help you to implement the most common requirements. So, enough slides. Let's just jump in the IDE and take a look at a little bit of code. So a common question that I get is, how can I find out which queries Hibernate really executes for my use case and how long do they take? Well, with Hibernate statistics, you can get a lot of internal information about what Hibernate is doing, because Hibernate obviously knows pretty well what it's doing internally. So what do you need to do for that? You need to set the generate statistics configuration parameter to true. You can do that in the persistence XML like I do here, or what I prefer for real applications is to provide this as a command line parameter so that I don't need to change any configuration files. Another thing you should then do is set the log level for org hibernate stat to debug. And that's all. So let's run this simple test case here, which just selects an author by ID. And let's take a look what Hibernate can show us for this simple test case. The first thing you probably notice is this part, where Hibernate gives us a good overview about what happened during this session. So we can see how long Hibernate spent on all JDBC statements and how many JDBC statements Hibernate executed. And you can see that here there are a lot of other information. If you want to dive deeper into this, then definitely take a look at the Hibernate statistics, either in the documentation or I wrote a blog post about that, which explains that in great detail. Another thing that you get is this line here. And this is pretty handy if you recognize, well, my use case takes longer than it should. Because here you can see, okay, I executed this query, it took this long, and it just returned one row. If you have performance problems, you quite often then see, okay, this query either takes long, then it's most likely something that you need to analyze in your database, or you're maybe returning not one row, but a few thousand. And there is almost never any reason to really read several thousand records from the database into local memory. A question that I then often get, and that always surprises me a little bit, is, well, why can't I use pagination with JPQL? Because the issue is, you probably know limit and offset and other ways to limit the number of result set records in an SQL query. JPQL doesn't support that. But we don't need that in a JPQL query because the query interface provides us with the set max result and set first result methods, which do exactly the same. And that allows us to use the same approach for JPQL and criteria queries, which is quite nice. And when we execute this test case, you can see here that Hibernate used this information to put a limit clause to the SQL statement that it generated. Okay, another thing that is quite useful with Hibernate is this one. So if you're working with JPA and Hibernate, you probably know that you can model associations in your entity mapping, which is nice and comfortable to use. You just call a getter method, and then you retrieve the association, and you can use these associations in your queries. But sometimes we don't want to model all these associations in our mapping. For example, here I have a book entity and a review entity. And if you have a huge online bookstore, then you might have a book with several thousands of reviews. And you would not want to load these several thousand reviews into memory. So you might not want to model this association. Unfortunately, with plain JPA, you can't use, or you need this association to join the book with the review entity in your query. But not with Hibernate anymore. There we can finally, since Hibernate 5, join the book entity with the review entity in this example with a join clause that looks basically the same as we know it from SQL. So we finally have that with Hibernate. I hope that we will get that in the near future with JPA as well. Because let's be honest, there's no reason to not use such a join statement in a JPA query. And the result is, well, what you probably expected. It's basically the same as you would write if you create your SQL statement yourself. It's just an inner join with an on condition that defines that we want to join it via the book foreign key to the book table and the book ID, which is just the typical on clause. Well, if you're talking about SQL statements and SQL snippets that we want to use, then you might be familiar with the formula annotation as well. Has someone used the formula annotation in the past? Okay, this is an annotation that is a little bit special. You shouldn't use it in huge applications that have to handle lots of parallel users or where you need the best performance. It's more something that you might want to use for an application that is used within a company where it's more important to get the job done quickly than getting the best performance in the end. The formula annotation allows you to define an SQL snippet, which Hibernate will add to all queries that load this entity. And the result of the SQL snippet will be mapped to an entity attribute. So here I use it to calculate the age of my author. So I obviously don't want to store the age in the database itself. I would need to update it basically every day and check, well, is it his birthday or her birthday? Do I need to update the age or not? I can use this PostgreSQL function and just calculate the age, similar to what I would do in my business logic. And when I now run the test case, you can see that Hibernate adds this snippet to the SQL query. As I said, please be careful with, here it is, with these formula snippets. They are added to all queries. And whatever you do in this SQL snippet, it creates an overhead if you don't use the age attribute in this case. So either make sure that the attribute that you annotate with the formula annotation is used in all important use cases, or be pretty sure that that performance is not one of your most important requirements. Database views. Who uses database views? And who maps them to entities? Yeah, quite a few. Well, as long as you just perform a select statement, then a table is pretty similar to a view. The SQL statement basically looks the same. And you can map them to an entity. You can see that here. It's a book view. I annotated it with entity, and then there are a bunch of attributes. One thing that's special is the immutable annotation. Quite often, you can use views for read operations, but you can't use them for write operations. So it's a good thing to tell Hibernate about that. You can do that with the immutable annotation, and then Hibernate will exclude this entity from all dirty checks. That means you could change any attributes of this entity if you provide setter methods, but Hibernate wouldn't replicate this change to the database. And it also wouldn't throw any error message. You would just not recognize that your change attribute wasn't persisted. So I highly recommend, if you have immutable entities, that you only use getter methods and don't provide any setter methods so that no one can change any attribute value. Another handy mapping operation, annotation, is this one here. It's another annotation that is quite useful if you have an application that you want to finish quickly and that doesn't need to handle too much load. Here, I decided to load the author entities that are associated to books, so basically all authors who wrote a book, in the alphabetical order of their last and first names. I could do that within a query, but if I say, okay, I will mostly access the author list via the getter, and I really need them always in this specific order, then I can also define the order clause via this order by annotation. If I now run this test case, then we can find the order by clause that I defined in the annotation here at the end of my query. So Hibernate takes the SQL-snippet from the order by annotation and adds it at the end of each and every query that initializes my author association for the book entity. Again, if you use that, please make sure that you always need the author in this specific order, because ordering takes a little bit of time, at least a little bit, and there's no need to spend that if you don't need the authors in that order. And if you need them ordered in some use cases and not ordered in others, then it's most often the better approach to just use a JPA query to load the author entities and order it within the query. Database functions. Who uses database functions? Who would like to use database functions? If it would be easier. Well, a few more. Still not that many. Okay. As with all features that are supported by your database, as soon as you use JPQL, your capabilities are quite limited. JPQL can do a lot less than SQL. And that's also the case with functions. JPQL supports a small subset of the functions that are part of the SQL standard. And unless they are added via the database-specific Hibernate dialect, it doesn't support any database-specific functions. But what you can do is you can use the JPQL function to call any function that you want to call. So in this case, I call the function calculate with these two parameters. So basically the price attribute of the book and a bind parameter value that I set down here. So right now with Hibernate 5, we have a few limitations here. We can easily use the function in the where clause. Unfortunately, we cannot do the same in the select clause, because there Hibernate needs to know which data type or function returns. It can guess that here in the where clause, but it can't do that in the select clause. So if you want to use it in the select clause, you need to define the function in your Hibernate dialect, and then this whole function approach here isn't of any use anymore, because then you could use the function directly within your JPQL statement. But for the where clause, it's quite nice. And you can see here that I now have the calculate function, which I referenced here, now have here in my SQL statement. Another handy feature of JPA is the Metamodel. Do you use the Metamodel? Well, maybe a few. Okay, the Metamodel provides us with a way to define queries with the criteria API in a type-safe way. And that are these classes here. So if I add the following dependency to my Maven build, this JPA model again, then Hibernate will generate the Metamodel classes or the Metamodel class for each entity in my project. What is a Metamodel class? A Metamodel class is this. So it is the Metamodel class for this book entity, which has an ID, version, title, publishing date, and publisher, and author's attribute. And as you can see here, you have the same attributes within the static Metamodel class. And that enables us to reference these attributes here in a type-safe way when we build the criteria query. The huge advantage, well, there are basically two huge advantages compared to plain strings. First of all, I don't need to remember and correctly type the name of each attribute. That makes it a lot more comfortable to implement the criteria query in the first place. But what is even better is, as soon as I refactor my entity and rename one of the attributes or the entity itself, then the next build will generate the new Metamodel classes, and the old version of the attribute will no longer be available. So my build will fail with a compiler error, and I will see all the places where I need to refactor my code in the IDE because the name of the attribute changed. Well, that might not be the best tooling that we could wish for. I mean, it would be even better if all these places would be adapted automatically, but it is by far better than using the search functionality of your IDE and searching for a string with a specific name, especially if the string is called ID or node or something else that is basically used on each and every entity. So how do you model your primary keys? Do you use UUIDs? Okay, who uses UUIDs? There are basically two options to create these UUIDs. I can do that in my own code, which is definitely a good idea, but I can also use an easier approach if it's fine for me that Hibernate will do it when I persist the entity. So you probably know that Hibernate can generate normal surrogate keys via a sequence or an auto-incremented database column. And it can do the same with UUIDs. The only thing you need to do is use the data type UUID, which is class in the Java util package, and annotate it with generated value, like you would do with a primary key of type long. So in this case, Hibernate will use a random number-based algorithm to generate a unique UUID. Let's take a quick look at the test case. So you can see here that I'm persisting a new author and then retrieving it later on. And as you can see in the code, Hibernate here generated this very cryptical looking UUID as the primary key value, and can then use it to retrieve the UUID, the entity later. That's not the only approach that or algorithm that you can use to generate UUIDs. You can also use this approach, which uses not a random number, but the IP of the server to generate a unique UUID value. And as you can see here, that requires a little bit more work, just because it's not the default algorithm. So now I have to explain to Hibernate, well, don't use the default generator. Please use this UUID generator with the custom version 1 strategy. But still just one annotation that I need to add here. And when I now run the test case, then you can see here that the UUID now looks a little bit different. So Java 8 brought, quite a while ago, some interesting changes. One of them was optional, which enables us to show in our API that there is an attribute that might be null. Well, with associations, we have exactly this situation. To one association could be null. For example, here a book and a publisher. Nowadays, you can do self-publishing pretty easily. You don't need a publisher anymore. And you need to model that in your domain model. Unfortunately, you can't use optional as an attribute type. There are several reasons for that. It's not serializable, it's not supported by JPA or Hibernate, and that will most likely also not change in the near future. So you need to apply a little trick if you want to use optional. First of all, you need to annotate your ID attribute with the ID annotation so that Hibernate uses reflection and called field access to set the values of your entity attributes. Because when you do that, then Hibernate doesn't care what you do and how you implement your getter and setter methods. You can do whatever you want. So for the publisher, I can go here and change the return type of my getPublisher method from publisher to optional publisher, and I can create the optional of nullable of my publisher. And if we take a look at the test case, you can see here that I load the book with ID 1, check that the publisher is present, and do the same with book 2 and check that it's not present. And you can see here that the book Java Persistence with Hibernate, which is a pretty good book, was published by many publications, and that my Hibernate tips book has no publisher because I self-published it. So this little trick, just annotate the primary key attribute with ID and then implement the getter method so that it wraps the attribute value, does the job to provide or to use the optional in your entity definition and to show everyone who uses the entity that it might be null. Another good change in Java 8 was the new date and time API. Is there anyone who misses the old Java util date? Well, me neither. The new date and time API is much better than the old one. Unfortunately, JPA 2.1 was released before Java 8. So JPA 2.1 didn't offer support for that. It was introduced with Hibernate 5 as a proprietary feature and is now part of JPA 2.2 as well. And we can now use local date, for example, without any additional annotation. We don't even need to annotate it with temporal. Why? Because we finally have classes that represent a specific type, a date. There's no discussion about any time byte if you use a local date. So Hibernate has all the information it needs by saying, okay, it's a local date, and it knows exactly how to map it to the database. And you can see here that Hibernate now persists the local date attribute that I use in the code to an SQL date column. Yeah, but what do you do if you can't use proprietary features in Hibernate 5 and you're still stuck on JPA 2.1? Well, you don't have any support for the date and time API, but what you have are attribute converter. An attribute converter provides a quick and easy way to transform an attribute type that you use in your entity model to a type that Hibernate knows how to persist in the database. So in this case, I map the local date class to a Java SQL date. Why? Well, you see that down here. The main reason why I use an SQL and not a util date is that the SQL date has this nice value of method that converts my local date to its database representation and also provides the inverse operation. And that's the only thing that I need to do in an attribute converter. I just need to implement these two methods, and in the best case, it is as easy as it is here, and I already have all the things that I need. What you also need to do is you need to annotate the class with converter. And in this case, you should also set auto apply to true. That tells Hibernate to use this attribute converter for all entity attributes which are of type local date, which is most likely the thing that you want to do here because local date is not supported with older Hibernate versions. So if we now do basically the same as we did before, just persist an author entity and load it again afterwards, then you can see here that Hibernate calls the method that converts the local date to a Java SQL date when it executes the insert statement, and after it got the record from the database, it calls the other method to perform the inverse operation and transform the SQL date that it just got from the database to a Java time local date. Okay, for this one I need a few slides. Who of you uses multi-tenancy? Yeah, becoming more and more people who are using multi-tenancy. It's the general idea is that I implement an application that can serve multiple completely independent clients. It's a typical scenario that I have in web applications where I want to serve multiple of my customers, and these customers want to separate the data from each other completely. If you offer, for example, a CRM system as a software as a service, your customers might be interested in the customer information of their competitors, but I'm pretty sure that they don't want to share their own data. So there you need to separate the information so that each of your customers, in this case called tenants, can work on their own data without sharing any information with other tenants. There are, in theory, 3 different concepts that you can use to implement that. Hibernate implements 2 of them, at least right now. The first one is this here. That's probably the easiest and most obvious approach. Each tenant gets its own database. So you have multiple tenants that are using your application, and your application decides, okay, this is tenant 1, so I go to tenant 1 database, and for tenant 2, I go to the other database. Another approach that I can use is the separate schema approach. There I use the same database, but I have separate schemas for each tenant. And within that schema, I have a bunch of tables, and the data is again completely independent. What Hibernate doesn't support right now is to share the same database and the same schema with all tenants and just add a discriminator column to each table to identify to which tenant each record belongs. That's right now not possible with Hibernate. If you want to do that, you need to use Eclipse Link. The reason why Hibernate doesn't support that is because Hibernate uses different connections for, or handles the multi-tenancy setup on the connection level. We need to do a few things for that. Don't worry, it's not too much that you need to do. You first of all need to activate multi-tenancy and define which approach you want to use. In this case, I want to use the schema approach. And then you need to implement two interfaces. You need a tenant identifier resolver. That one is responsible to identify which tenant belongs to the current user and should be used right now. And then you need a multi-tenant connection provider, which selects the connection that has to be used with that specific tenant. So I implemented these two interfaces here. Let's take a look at this very simplified example. Why did I simplify it like that? Well, identifying which tenant is responsible or active right now is something that is far outside of the responsibility of your persistence solution. That's something that you do most likely during login. So you might extend your authentication and authorization component to identify which tenant is active right now and store the tenant ID in a thread local, for example. So here I just provide a setter method. So you can see it's not part of the current tenant identifier resolver interface. That interface just requires us to implement these two methods. And then we have the multi-tenant connection provider, which provides the collection. This, again, is a simplified example. Because in general, if you implement a multi-tenant connection, then you have a huge stack that you use for your application, because you're using a complex, or you're building a complex business application. So you have connection pools, which provide you with the connections to your database. And you would most likely use them here in the multi-tenant connection provider. A typical approach would be you configure a pool for each tenant that you want to serve with your application, and then you would select the specific connection pool that you want to use for your tenant. Here I kept it a little bit simpler, just to make sure that we just need to use Hibernate. The approach is always the same. So here I have my connection provider map, which is a simple map with a string and a connection provider. The string is the ID of the current tenant. And then I create the connection. I use Hibernate's driver manager connection provider impl for this. This one is good enough for presentations or to learn about the general concept of multi-tenancy here, but please don't use it in production. And the two important methods are these down here. Hibernate requires you to implement the getAnyConnectionProvider method, which just needs to return any of the connection providers that you have available. That's for administrative use. And then we have the selectConnectionProvider that gets the tenant identifier as a parameter. So here we need to select the specific connection that is valid for that tenant that's currently working with our system. Let's take a look at a simple test case where we use that. Okay, you can ignore this line. That's just because I fake the authentication and tenant identification here and set it hard on the current tenant identifier resolver. What you would see in a real application is basically this part. So we open a Hibernate session, start a transaction, persist a book. This one is for tenant 1, so I call it book of tenant 1, and we do the same for tenant 2. The only difference here is this part. The persistence code isn't affected by this change. So you could easily add the multi-tenancy feature to an application that you developed without thinking about multi-tenancy. If we now run the test case, we see not that much. We see Hibernate gets a value from the sequence, inserts a book, and does the same here again. But if we take a look at our database table, then we see that in, where is it here? That in the book table, in the database schema tenant 1, we have only books of tenant 1. And if we take a look at the schema of tenant 2, then the book table, then we see that we have just books of tenant 2. So without adapting our business code, just by adding these two interface implementations and making sure that the correct tenant identifier is set on the current session, Hibernate takes care of multi-tenancy and decides, okay, this is tenant 1, all operations go to this schema, and that one is tenant 2, all operations go to the other schema. The tenants are, at least from a data point of view, completely separated from each other by implementing two simple interfaces. Is there a question? Okay. Another typical business requirements nowadays is auditing. The goal here is to document all changes that were performed on the data. So we can, of course, use database triggers to document all of that. Or we could use Hibernate Envers, which is a Hibernate project that integrates into Hibernate ORM with lifecycle listeners and writes additional information to the audit tables. There are a few things that we need to do for that. First of all, we need to add this Hibernate Envers dependency to our project. And then we need to annotate all entities that we want to audit with audited. You can see here there's nothing else that I did on the entity. But if we look at the test case, well, first of all, we can see here that I, again, don't change anything. I just persist a new book, and then I read the book and change the title. And we can see here now that Hibernate performs quite a lot of operations. So let's start with the insert statement, create table here. So I first created a book. Right, it's no surprise Hibernate gets the primary key, inserts the record into the book table. But the following insert statements are part of Hibernate Envers. Hibernate gets another sequence value and creates an entry in the revision table. This revision will be associated with all changes that we perform within this one transaction. And then Hibernate writes a record into the book audit table. That's the default for all audit tables. So when we annotate an entity with audited, Hibernate maps the entity to a database table with the same name by default and adds _ AUD to it to the table name and uses that as the audit table in the database. So instead of performing one insert statement, we are now performing one into the book table, one into the revision table, and one into the audit table. And after that, I started a second transaction and updated this book entity. And you can see here that I now read the book entity, perform the update on the book, and then Hibernate documents the next operation in the audit table. So it writes automatically a revision entry and a book record into the book audit table. And you can take a look at that here. So we have the ref info table. You see now here that Hibernate wrote 2 entries to this table, which were the first revision, which created the book entity, and then the second revision, which updated it. And we have here the book audit table. And here you can see the entries for the different changes on that table. The ID of the record in the book table and the ID of the revision in which it was inserted, created, or inserted, updated, or deleted are the combined primary key. And then the ref type identifies the kind of operation, 0 for insert, 1 for update, 2 for delete. And then you can see here the values that the book record had in that specific revision. And you can then go to, or if you want to use that in your project, you can take a look at the Hibernate Envers documentation. You can easily adapt the revision entity and add user information, for example. That's a pretty common requirement, that we not only need to document when did what happened, but also who did it, which is not part of Hibernate's standard revision, because that's again related to user information, and that's outside of the persistent logic. But you can easily add your own revision entity which adds these information. You also get an API to query data from your audit log, either vertically, where you take a look at all changes that were performed on a specific record, or horizontally, where you basically go back in time to a specific timestamp and take a look at your data, what was valid then. Okay. And then we reached the end, and I'm happy to answer further questions. Who has a question?
Yes, about multi-tenancy. Is there any performance drawbacks if you have several documents?
No, that's totally fine. At least from a Hibernate point of view. The multi-tenancy approaches apply different kinds of isolation. I mean, if I have a separate database server for each tenant, then I can be pretty sure that everything that I do for tenant 1 has no effect on tenant 2. That's not necessarily the case if I have 2 schemas that are hosted on the same database server. There it can happen that the resources that are used for tenant 1 are not available for tenant 2 and impact the performance there. But that's a general thing that happens if I host multiple things on the same database server, and that's not directly connected to this multi-tenancy approach. Another question? The question is if the audit trail would affect the performance, and yes, it definitely affects the performance. So if you take a look here at the log, then you see that you perform a lot more database operations than you would normally do, about twice as many, at least for all write operations. Another thing you need to be aware of is that you write the audit log by monitoring the lifecycle state changes of your entities within Hibernate. which is easy and comfortable, but you miss everything that's performed outside of your Hibernate persistence layer. And that are the two main disadvantages of Hibernate Envers. It increases the amount of database operations and therefore slows down your application. But that would be the same in at least most situations for database triggers. And you might miss a few updates if you use other tools that also work on the same database. Any other question? Okay, then thank you and have a nice evening.